For my second LB274 physics project, I decided to look at computer sustainability. But why computers? Computers are all around us these days, and there is little we can do to avoid them. Whether it's the miniature ones in our pockets that we call our smartphones, the desktops we use in the library to study, or the laptops in the physics studio room, they are very prevalent in our life. And we use them, especially now when we can't really leave our homes due to COVID. When we talk about computer sustainability, there are really two major categories to be had there. The first of which is raw materials, and there are resources that go into computer making and iPhone and smartphone making. You can see aluminum and steel and copper, and silicon. These are very prevalent materials and resources that are present um, in our phones, in our daily lives. On a somewhat personal relevancy standpoint, this is my build when I built my computer over the summer, which is and then I built some others people's. It's kind of a side business. You can see in the photos on the on the right, and the photo on the left is me trying to fix the fan on my laptop. They're all around us. Computers are everywhere. And before we can talk about any sort of circuitry, the main thing we have to look at is the circuitry inside of this. Well, what is this, you may ask? This is a power supply, and it has one purpose: to take the power from your outlet and convert it into usable power for your computer and for your circuitry in your computer. While this may look overwhelming at first, this is basically any other circuit diagram. Here you can see an AC input from like our outlet, which converts all the way to a DC output, which is then put into our system and our computers and iPhones can readily use. And that's the major component and the key component inside these power supplies. This entire system is known as a full bridge rectifier, and specifically if you look at the rectification step, uses this one as a 4-diode configuration to make the electrons flow in one direction. This whole idea of a direct current. Uses a 4-diode configuration, which then converts this 4-sinus configuration into a more DC pulse waving kind of interaction, which after some regulation converts into a nice clean DC power for our computers to use. Now that we have some basis as to how power is used in our computers, let's take a look at real-world application of computers. I decided to focus on idle power waste in physics classrooms. And at a practical level, there are about 30 laptops in E5, each using around 2 on average watts of power while they're sleeping, which is what we do. Unfortunately, we don't turn them off. And across all the sections, we have around 144 hours of downtime a week. If you calculate that out and times it by 25 cents a kilowatt hour, which is real world what you would pay, not necessarily the price per kilowatt, the school uses about $69 on average to power these computers and just standby idle power, which is crazy. So what can we do better? Well, first and foremost, we can do better is start turning things off instead of just putting them in sleep mode, which is what we currently do in physics. Right now, at a maximum of 3 watts an hour, we can turn it all the way down to 0.3 watts an hour if we turn each laptop off. Right? And that's about $63 a school year. Now, it may not seem like a whole lot, but over the course of quite a while, it can be. And sustainability is all about incremental steps. It's what everyone can do to share in the sustainability effort. The second thing is I think we have a little bit too many computers. There's a lot of computers that aren't in play in both in the students' active like while we're in class and especially outside when no one is in physics and they're just sitting there. Right? I think the physics department should talk with their Holmes Hall or Lyman Briggs College, see if some sort of rental program is possible. They do this with spare keys and IDs in the front office, and maybe if we can get in contact with some students that maybe not have access to computers and see if we can rent them out. And it doesn't, and so like if you don't return it, then you have to be fined. But we have them. Let students have access to these. These are our students. And then here's my works cited.